Hello, I'm George Malin, the Managing Editor of Vanilla Plus. Welcome to today's webinar. The topic today is microservices. And microservices are obviously everywhere and are already being deployed in the market by companies like Google. I think there's a very interesting opportunity for CSPs here, and that's very good because today's session is titled Microservices Are Everywhere and What CSPs Can Learn from IT. I'm very pleased to welcome today's panel, which is composed of Sita Somagani, a Solutions Architect at VaultDB, and John Abraham, a Senior Analyst at Analysis Mason. But before I hand over to today's presenters, I'd like to present to the audience the first of today's polls. The first question is, what stage are you in with respect to embracing microservices-based architecture? And the possible responses are, not started yet, experimenting with some use cases, solutions are in the testing stage, and that's before deployment, and you have solutions that are in live production. I'll just run through the questions and the possible answers again. What stage are you in with respect to embracing microservices-based architecture? And the possible answers are, not started yet, experimenting with some use cases, you have solutions in the testing stage, and that's before deployment, or you have solutions in live production. And just before we look at the response to that, I would point out that our panelists are staying on after their presentations to take live questions from the audience, and I'll be presenting those questions to our panelists after their presentations. Now let's see what the findings of the poll were. So that's very interesting. There's a solid 45% of respondents who are in the experimental phase looking at use cases. Another quarter have not yet started, which I think would be consistent with the state of development in the industry at the moment. But although encouragingly, there's almost a third, if you take both categories of solutions into account, that are at least either testing or even in live production. So I think that's very encouraging. With that in mind, I'll pass over to Sita Somagani, who will talk through his presentation now, and I'll pass over to you, Sita. The floor is yours.
Thank you, George. Just to clarify, John Abraham, I'll be doing the first section.
I do apologize, John. I've introduced Sita in error. It's John Abraham, the Senior Analyst of Analysis Mason, who's giving the first presentation. He'll be followed by Sita Somagani from VaultDB. John, sorry about that. Not to give you a good introduction, but at least you have an introduction now. Over to you.
Thank you. Thank you, George. All right, so that survey results was quite interesting. 60% of you responded with, responses in the middle, either experimenting or testing, which pretty much sums up what I think is where the industry is right now. Intense stage of experimentation and, slowly evolving into the next stage, which is going live in bits and pieces. All right, so I would like to begin with an evolution picture of how cloud computing technologies have evolved over time. And this is predominantly an IT perspective, but it still gives us a lot of indication as to how cloud native came to be. So it begins in the 90s, phase 0, which is the time of monolithic applications and a one-on-one mapping with an application and a server. And then in the early part of the century, we evolved into virtualized applications, which completely changed that equation. It became one server to many applications. And then further along, we evolved to a cloud-ready mode, which is an application that is hosted in a cloud and functions under an orchestration layer with some level, not extensive, but some level of decomposition. And that was phase 2, which then finally evolved into what we call phase 3, or cloud-native stage, which is where applications are deployed as microservices within containers. And what that really means is that all applications would be broken down or decomposed into small functions, microservices, and it could be done as a way of completely rebuilding the applications itself, or some form of refactoring of the older applications. But pretty much that is phase 3, the stage that we are in today. We'll talk a little bit more about that in the coming slides. But I also want to point out that through this transition, obviously the underlying infrastructure has shifted considerably as well, from a on-prem model to a multi-cloud model. So moving on to the next slide. So I have taken the liberty here of actually introducing introducing a slide that actually defines what microservices is. And part of the reason is that I have observed there's a lot of misconceptions in the market about what microservices or cloud native computing truly is. So for the sake of definition, I'm going to lean into CNCF. CNCF, by the way, is the Cloud Native Computing Foundation. It is a non-profit, part of the Linux Foundation, and it is basically established to drive the adoption of cloud native technologies. So according to the CNCF, cloud native systems will have 3 key characteristics. The first one is that applications can be decomposed into small micro units called microservices. And this is where that phrase microservices comes from. I just want to speak to that for a moment. I have observed that in the industry, the term microservices is often used interchangeably with the phrase cloud native computing or cloud native architecture. And it more or less means the same thing, when the user uses those 2 phrases. So just to clarify, cloud native computing is the grand picture of the architecture model, and microservices is a component or a constituent within that, a key requirement of becoming a cloud native system. All right. Moving on, the second key characteristic is that these microservices can reside and live within a container. So the container, you can think of it as a lightweight virtualized environment, that can encapsulate the entire application and at the same time isolate it from the rest of the system. So that is container. And the final characteristic is that these containers, these application containers, can be orchestrated and managed by a centrally orchestrated and managed. So there you go. That's the 3 key pillars that would, prerequisite, I must say, that actually makes an application cloud native. That, they can be decomposed into microservices, they can be containerized, and they can be centrally orchestrated. All right, so what is the big deal around microservices? Why is there so much buzz around this phrase? I think the best analogy I've heard is around how, in the past we used to have big buildings, and then what happened is that architectural steel was created, and then which led to the creation of skyscrapers. So going from just big buildings to skyscrapers was a massive step for the construction industry. And that's exactly what cloud native does to modern systems architecture. It just takes scalability and extendability and modularity to a completely new level. Now, in terms of what is going on within, or who is leading the innovation within cloud native computing today, it's for the most part being driven by the digitally native companies. And a good example to compare is the FANG companies, which stands for Facebook, Amazon, Netflix, and Google, and what they have been doing in terms of experimenting and incorporating new technologies and embracing them in their core operations process. Now, obviously, this was not the case always. I think if you go back about 2-3 decades ago, operators were actually at the forefront of innovation when it comes to technology, or to a large extent at least. But what actually caused that shift was the advent of cloud, and with things moving to the cloud, that equation changed dramatically. So that's the key takeaway from this slide, which is architectural agility is pretty much what sets the leaders apart from the traditional also-rans. So on this slide, what I have attempted to do, I know it's a busy slide, is have a list of benefits that actually microservices bring to the table, for a traditional industry, like an operator, like a CSP, for instance. So in this case, on the left side, I have some of the key benefits there, and I won't go through it one by one, but I just want to speak to a couple of them, at least, which is a big concern for telcos today. One of which is the ability to have continuous delivery and continuous deployment. So today, if you look at how monolithic applications are deployed, there is always a big delta between the time when an upgrade is available to the time when it is actually deployed. For numerous reasons, one of the key reasons is, especially within a multi-vendor environment, is concerns if upgrading application A would break application B, C, and D, which all connect to application A. So that's often a key concern that slows down the progress of implementing upgrades in patches, especially. But with the way microservices are designed, it actually makes that way more seamless, partly because it actually aids continuous delivery. I mean, you can continuously do drops into your core architecture that allows you to overcome any bugs and fix them, without going through a long process of releasing it and then, waiting for the end user to deploy it and so on. And the other key aspect that I want to call out is extreme automation. And again, automation has been around in some form, especially as some form of scripting for a long time. But the way microservices are designed, especially within independent containers that is isolated from the rest of the system, this actually allows for a greater degree of automated systems, and processes that actually save significantly on costs and resources. Obviously, this is a long-term journey, but even then, the benefits that this would bring would be tremendous. On the right side, very quickly, what I have is I've just a table that compares the current mode with a future mode of operations, assuming the future is fully cloud-native led operations. And you can see that there is significant efficiency, and that's a big word there, efficiency, in terms of employees, systems, processes, and overall operations. So again, just to summarize this slide, I guess the buzzwords are agility, automation, and extendability. These are the three key things, at least the top three things, by no means exhaustive, that microservices actually brings to the table from an architecture perspective. So before I actually step into a discussion about what type of operators are best placed to embrace cloud-native models, I want to briefly introduce three categories of operators. This is from our research and the way we see it. And on the left side, so you have the skeptics, who are, generally in a wait-and-watch mode, when assessing innovation or new opportunities. And they generally have very little market pressures on them to become digital. The middle bunch, the hybrids, which, by the way, is where a substantial portion of the operators tend to be, they are risk-averse, and they usually prefer stability over innovation. But at the same time, they have a deep desire to become a digital service provider eventually. However, they will lean into vendor-led innovations to get there. And on the right is the true believers, which is the ones, who have the funds, who are quite aggressive, and, who have a large appetite for risk-taking, and who are keen to experiment and explore and, embrace and, if possible, adopt new technologies within their core operations. So that green box that you see, what I have attempted to do is a form of a heat map that captures which operators are most likely to embrace and experiment with, cloud-native computing models. So obviously, the major chunk of experimentation and not experimentation, I would say what goes beyond that is actually within that bottom right corner, which is where the bleeding edge of true believers are. But in a short few years, I expect that green to expand considerably to the left and take up a significant portion all the way up to the hybrids bit. All right, so moving on to the next slide. So now that we know what the three categories are, I must insert a caveat here that not all operators may want or need to embrace a cloud native model. We just talked about the skeptics, who are comfortable staying on the extreme left and watching and waiting for the other things to mature. But the true believers, the ones who actually, the operators who actually see themselves as a leading part on the leading edge of the industry. I have tried to list out the top three things that they could do to expand the adoption of cloud native. The first is probably the most obvious one, and this is that it has to be driven from the top. And this might sound obvious, but the adoption of cloud native computing involves a significant level of change and transition and discomfort that without senior executive support, preferably from the CX suite, it's likely to fail, and that is just the internal bit. I also think that there is much that the operators could do externally in pushing their vendors to embrace cloud native technologies, not just at a technology level within their solutions, but also broadly, in terms of processes that the vendor adopts to deliver their upgrades and solutions to the operator. The second bit there is, that the operator should identify niche use cases or maybe some greenfield use cases where they can actually test out this microservices-based architecture. The thing is, this is quite radical enough that at least initially it is best kept out of the core operations and tested out to the side. I think one key learning for the operators, especially from this exercise, would be the effort and the different way of doing things that they would learn from undertaking something like this at a small scale. And finally, the point about influencing the industry, which I think is quite important. See, as I mentioned earlier, what's happening today is that much of the narrative and the innovation around cloud native computing is driven by the non-telco. So, and that's where much of the story has been, if you look at the past 5 years especially. But the problem is telcos, as they begin to work deeply with cloud native technologies, they're uncovering issues which are quite unique to them. And they need to have a much more firmer voice to raise these concerns and get the industry at large, to work around that and gather around it and fix those problems. So I think there is a responsibility on telcos to actually, do a little bit more of an play a bit more of an influential game at a higher level. All right. So in this slide, what I've attempted to do is just on the right you have the CNCF tooling taxonomy, and I just wanted to highlight the fact that this journey can be quite a complex one, and it's very essential that operators make the right choice when it comes to selection of the vendor partners or even the approaches that they want to embrace in taking this forward. So one aspect of that is that there is a lot of discussion, for instance, going on right now around the sanctity of data. So as I mentioned earlier, there is the microservices tend to be stateless, which means they do not hold much information, and they do not hold a valid state at any point, which means the role of the centralized data lake becomes all the more important. But the problem is that within multi-vendor environments, especially, that can be a big concern because different vendors might have different data models, and getting data to work together is a challenge. So Sita, who will actually come after, take over the next bit, will be talking about some of the challenges around data sanctity, especially. So the key summary is that embracing cloud-native computing is a long journey, and operators need to do that with very much care, especially in selecting the strategy and the partners for that journey. So my final slide here, I just want to talk a little bit about some of the key trends and also some operator use cases. So from a trends perspective, what we are seeing is the industry is pretty much standardizing around Docker and Kubernetes for cloud-native applications. So Docker is a container format, and Kubernetes is the de facto standard for orchestration today. Both of these are based on open source technologies. So Docker has its own secret sauce on top of that. Kubernetes, by the way, evolved out of Google, and now it's governed by the CNCF. Broadly, I think it's a good development, the fact that we are having some standardization around, especially the core technologies, that can be built on top of. However, I do think that most of this has been driven by the non-telco enterprise. Telcos are just beginning to get into the game, and I suspect we already have started to uncover some requirements, which Docker and Kubernetes may not do to the best. So I suspect we might actually be at a time where more new technologies would pop up that would rival what Docker and Kubernetes can do and would speak especially to telco requirements. The second one there, which is that the non-real-time use cases are being prioritized for the initial wave. I think it's an obvious thing, but just want to flag up that telcos right now at least are not experimenting with any mission-critical, low latency applications with when they work with cloud native. That also highlights one other problem, which is when you look generally at the retail or entertainment industry, the nature of real-time applications are not mission critical. It's more like nice to have, but it's certainly not mission critical to the extent that it is for telcos today. So that's also one other reason why telcos are taking a bit longer to refactor and embrace cloud-native computing. And finally, the last point around multi-vendor environments, I briefly alluded to that earlier. So the concern is, again, much of the narrative today around cloud-native computing is driven by non-telco, where this is not much of a concern. But when it comes to telco environments, pretty much all telcos have multiple vendors there, which needs to speak to each other and play nice with each other. And this problem becomes all the more a bigger concern when they deploy, microservices. So increasing concern around this topic, and we are seeing more and more discussions and more operators wanting to know how this can be fixed. All right, now quickly to the use cases. So first of all, apologies. I cannot call out any operator or even any vendor by name, but I just want to point out that right now most operators are at the experimental and initial test bed phase, even with live deployments, and they are a bit cautious about giving away too much information. So that's the key reason. But the first one there is about a large operator in the Americas region who actually worked to create a series of microservices. And this one is unique because they have adopted more of a cooperative model, which, by the way, is becoming a common theme, where the operator works on a few microservices, brings in a certain vendor to work on some where they do not have the essential expertise. Now, it's an open question how scalable this model is, especially if you want to go big. How quickly can the operator scale up to, drive such an initiative? I think there are concerns around that. But on the vendor side, a key highlight is that in such cooperative models, operators prefer to work with incumbents, at least most of the times that we tracked, rather than bringing in someone completely new. In the second use case, there is a tier one operator, again from the Americas region, who had multiple non-critical cloud-native applications in live production. What is unique about that was that when they had to deploy it, they figured out that they couldn't, I mean, even before they deployed it, they figured out that they couldn't test all the potential test case for these new applications because, that would have been too extensive. So they actually bypassed that stage and, tried to deploy it on production. It had a lot of challenge in actually, deploying something that has not been tested into production because that's not the way their teams are structured. And it even failed on production, but they quickly got over it, because they had a steady stream of updates that they could drop into it. But I think that actually highlights the fact that, this embracing cloud-native technologies calls for a radical change in how operators do business today and a radical realignment of workflows and maybe even a re-education of their existing employees to support the new models here. All right, so with that, I hand it back over to George, for the second poll question. Thank you.
Thanks very much, John. That was a really good scene setter. I think there's a lot to think about for the telecoms operators here because they're having so little involvement in much of the debate, and it's clear that time is ticking. Anyway, let's move on to the second poll question. The question is, what is your plan to handle the increasing data volumes with IoT and 5G? And the possible responses are: increase the footprint of the existing databases, explore the cloud database or platform as a service offerings from the big players, explore alternatives, including open source, and re-architect your applications. And the fourth response, don't know yet. Let me run through the question and answers again. What is your plan to handle the increasing data volumes with IoT and 5G? Answer 1, increase the footprint of the existing databases. Answer 2, explore cloud database platform as a service offerings from the big players. Option 3, explore alternatives including open source and re-architect your applications. And the final option, don't know yet. Just before we look at the results, I would urge everyone to feel free to ask the panel a question. We've had some good questions in already, and we'll be dealing with those after the next presentation. But let's turn and look at the results of the poll now. Interesting. By far the largest proportion would look at exploring alternatives including open source and or re-architecting applications. I think that's an interesting approach. And I think that the fact that only 7.7% are looking at increasing the footprint of the existing databases is actually significant, potentially on trying to keep cost control in place, I guess. And then there's a third of respondents who seem to be pretty honest and are saying they don't know yet, which I think, given what John was just saying, is probably a fair picture of the state of play and state of maturity in the telecoms industry at the moment. Great, thanks very much to the audience for answering that poll. Now it gives me great pleasure to hand over to Sita Somagani from VaultDB, who will now give us his presentation. Over to you, Sita, the floor is yours.
Thank you, George. Thank you everyone for attending this webinar. So let's skip ahead. So John did a great job clearly outlining the motivations behind the transition to cloud-native architectures and how the industry is in general, with this journey. What I would like to do is take a more of an implementation side perspective of this transition to microservice architecture, why that's needed, and give you a use case of how that has happened and how that is achieved with one of our telco customers. So I work at VaultDB. We are a vendor of a database product. Our database is a highly transactional relational database, which is ideally suited for high throughput and low latency applications. So I'd like to begin with trying to contextualize the importance or the place of microservices in today's industry in general. For this, I would like to use one of the talks that I heard on O'Reilly London last year, which was given by Mark Richards about the evolution of software architecture. So he contextualizes the current evolution of software architecture by placing it in the general grand picture of how information systems are evolving. So it describes the evolution of the information systems by using the vertical layers of hardware, software, human-computer interaction, social interaction, and interaction with the environment through information systems. So as each layer has evolved, it gave birth to a new layer above it. And the new layers are driving the evolution of the layers below it. So as software evolved from the traditional green screen applications to client-server to service-oriented architectures, it was driving the evolution of hardware to catch up and be able to support these newer evolutions of software architectures. And as human interaction with the computers have been evolving, we've evolved from using mouse and a keyboard to touch screens to actually wearable devices. So these evolutions in the way we interact with the computers are driving the evolution of software. And putting together all the evolutions of the layers on top of software, we see the embedded devices being embedded everywhere. And it's not just humans communicating with machines or humans communicating with other humans, but also machines communicating with each other. And through wearable devices, all of these are driving the software architecture, which has brought us to the place of microservices on this day. So we can take an example of Google, which is famous for writing all of their software as containers in microservices. And they treat their hardware as disposable servers. So if a server goes down, there is no immediate action required. This level of abstraction that they are able to treat their hardware with affords them the ability and being able to stick to the core design principle that everything except data should be treated as disposable and should be architected as such. So this picture really gives me the context to put this architecture, the microservices architecture, firmly in place. So we can define microservices in different ways. It's an approach to developing a single application as a suite of smaller services, each running in its own process and communicating with a lightweight mechanism such as like HTTP REST. Or you can also call them as, it's an architecture that structures application as loosely coupled services, and each is an independently deployable bounded context of business capabilities. But regardless of how we define microservices, we're making the argument that microservice architecture is firmly in place in the evolution of software architecture. To understand microservices from an implementation perspective, from a developer or an architect perspective, because we're speaking with them most of the time, those are the people we're speaking with when we interact with our customers, I thought I'll take a look at microservices from 3 different dimensions. What components do you build microservices from? How do you structure your teams so that you are enabled to build microservices? And what do you get by re-architecting your application as microservices? What are the system boundaries that you're able to achieve? Which is probably one of the core goals of building microservices. You are able to put boundaries between the different subsystems so that you have the finely granular control over your application, over how your application scales, how you build it, and how it is deployed. So looking at the components, the most important component is obviously containers, the container infrastructure, which is now the the default atomic unit of infrastructure over physical servers and virtual machines. Containers have their own obvious advantages over VMs, faster instantiation, better isolation, easier scale, less overhead, but doesn't necessarily mean that you must build microservices on containers, but that seems to be the norm. And what containers mean to me as a developer really is they give me the ultimate inversion of control. So if you have used Spring, inversion of control, that means you inject the dependencies, but you're not actively going out and seeking other modules. You just expect that those modules that your module needs will be provided to you. In the case of microservices, I can choose my own language. So I can choose my own web server. I'm not assuming that I don't have to start building my applications on the assumption that, okay, my service is going to be deployed on Tomcat, so these are the facilities that are available to me, or this is the messaging queue that I have to use, so these are the facilities that are available to me, and I have to make sure that my application sticks to that one single platform or one single application server. Rather, my application fetches its own application server, Tomcat or Engines or whatever it likes to use, and whichever language I decide to use, it doesn't matter. As long as I define a clean interface and build my component, which is, provides a clear interface for others to interface with. So in addition to containers or whatever the atomic unit of infrastructure that you decide to use, there's other components involved like data stores, because microservices are by definition should be built to be disposable. There are gateways so that you can interact with the system, messaging queues that are used to interact with the system and the different services among themselves, and monitoring and ops tools that you would use to see the health of the system, health of the individual services. So the lessons that we've learned from looking at different use cases is you don't have to start off from scratch by building on microservices. You can break the microservices out when a clear and worthy reason has been identified, whether that has to be to increase the performance, solve some issues, or to do some metric gathering for some sort of improvement you would like to do. So there's the argument of pets versus cattle that analogy is frequently used to describe microservices. You need to be able to treat your microservices as cattle, not pets, so that you're not getting attached to any single instance of your service, any single container. Rather, those should be disposable. If one fails, you should be able to instantiate another one automatically and add that to your application, add that to your running deployment. And which makes fault tolerance central to the design, because if one fails, you need to be able to add another one back in and have the application continue to perform in a reliable manner. We'll get into that in a little bit more detail further down the presentation. Looking at the dev practices, the important rule of thumb here that has been driving the way teams are organized to build microservices is the Conway's law, which states that an organization designing a system, assuming an information system here, will inevitably produce a design whose structure is a copy of the organization's communication structure. So if your organization, to put it bluntly, is everyone is sitting in the same floor and working together, the modules that are going to be built are going to be tightly coupled and communicating in complex ways, just reflecting the way the team has been communicating. Contrasting that with an open source project, the modules are more clearly defined, and this was proved from empirical evidence by Harvard Business Review. So what would you do to build your team to be able to build microservices? So dividing the team by layers, as in you have DBAs, group of DBAs, group of Java developers, group of front-end developers, sort of that, dividing your team into functional units where the teams are composed of experts from all different areas, database, front-end, middleware, and these teams work together and communicate with the other teams. So the distribution of teams, the composition of teams is important, and that is actually being put into practice at Google and Amazon. They are breaking their teams down into microservices teams so that productivity could stay high while in an extremely complex environment. And providing the right tools for the development teams to make the transition to a DevOps kind of a development, DevOps kind of an organization is also very essential. And this isn't just a burden on the teams to reorganize. It also frees them up and gives them the choice of which language do you want to use, which tools that you want to use. It's left to the individual team to choose that. And coming to the system boundaries, which is essentially the goal of microservices, being able to define different systems that can be scaled in different ways. So functional decomposition. I'll continue to break my application down into smaller units until they're manageable. And I will partition the data so that any shared data needs to be in one central place, but any data that does not have to be shared can stay close to the functionality that needs that data. And we can scale the individual services in a horizontal manner. We see the orders and booking module receiving more load, we can scale that horizontally. And the Heracos 12-factor apps is a manifesto that helps in writing your applications from scratch so that they can be built into clean modules that can work as microservices. And there's this excellent talk that was given by Eric Evans, presentation he gave, which he calls the domain-driven design in microservices at last some boundaries. So microservices is now enabling, his argument is that it's now enabling what has always been the goal of domain-driven design, to isolate your modules into bounded contexts that function independently and interact with each other. So there's a lot of advantages, of course. That's why we are pursuing microservice architecture. And what's the drawback? What does this new architecture bring us? These are summed up very well by Dr. Peter Deutsch at Sun Microsystems, who listed these out as the fallacies of distributed systems. When we were working on a single monolithic application, the network was pretty much not a concern of the actual application. The network was something that we just had to use, but we never had to deal with the reliability of the network, the bandwidth of the network, the security of the network, and whether the topology of the network changes, whether one service has to communicate with another, whether their IP addresses are going to change. These are the fallacies that a new developer can fall into, which are captured in this fallacies of distributed systems, and that we have to account for. So it's not only that we have to account for the unreliability and the security of the network, but also take into account the challenges of whether when an independent one of the services breaks, what would it take to continue to run the system efficiently? Maybe it doesn't give 100% functionality, but failing of one service shouldn't bring the whole system down. You know, if the rating system on Amazon.com happens to go down, that should not take down the orders or the whole website. So there are additional challenges. Building microservices is not easy. There are additional challenges that are both new and complex. So how do we approach those? Platform as a service is a great way to get started with your microservices. It's apparently PaaS and microservices are a match made in heaven, because PaaS, the definition of PaaS from Wiki is it's a category of cloud computing services that provides a platform allowing customers to develop, run, and manage applications without the complexity of building and maintaining the associated infrastructure. That sounds like infrastructure as a service, but at an application level. When you're building your application, you're building your application as a microservice. Whether microservice or not, you have the components that you need to build your application, especially when you're building it as a microservice. You have the basic demands of these architectures that traditional application delivery models and traditional middleware infrastructure do not address, such as on-demand provisioning, dynamic composition, and service level management. So PaaS provides you all of these and gives you components like load balancers, cloud controllers, manages and delivers your programming languages and frameworks to you, provides you policy controls, and interestingly also a marketplace of services so that you don't have to build them all. You can just purchase a service by the hour, provision it, your application can interact with it, and use it as part of your application. So as any platform initially promises, like this takes me back to the original Java days where, you know, when the advantages of Java were listed as it decreases the fragility of your solution because you're not writing specific code to handle these things that have already been thought out, have already been fixed. reduces the operational burden. You don't have to maintain a lot of code, just maintain your application code, and enhances developer productivity so that developers are focused on their problems. So the pre-built components and the framework that a platform as a service and the marketplace that gives you enables you to start building microservices much more easier than having to build them from scratch. So being from the database side of things, and that being one of the critical aspects of microservices, I thought I'll discuss how you would manage state. So microservices should be, by definition, disposable, meaning they cannot hold data or state. So coming back to the pets versus cattle argument, you have stateless, both stateless and stateful microservices. The stateless microservices are just simply those that do not have access to any state. All they do is handle requests and send out responses or send out events. The stateful microservices should have access to state, which is stored elsewhere, either based on the type of state, either if it's a persistent state, it can go into a database layer or a database as a service. If it's a configuration state, it should go into an environment variables as part of the definition of the container. The session state should go into the gateway. So there are different areas you can store the state. But importantly, as the data volumes increase and as we are dealing with, especially telcos are dealing with more data, and the potential to monetize your data, to monetize your network exists at every single level. And the sooner you can capture the data and act on it, the more monetization opportunities you would have. So moving on to the use case that we have worked with our partner and customer, Nokia. So Nokia had initially used VoltDB as the backing database for their telephony application server, the Nokia TAS. So as with any progression that companies make with their approach to microservices, as John had alluded to before, they started off with something that is not critical, that is not very core. It's not actually part of the core. But after they had implemented VoltDB as part of Nokia TAS, they have expanded it out into the Evolved Packet Core. Now their Cloud Mobility Manager and Cloud Mobile Gateway are powered by VoltDB as a database as a service. So this is part of a key evolutionary step that Nokia made as part of their NFV and strategy for 5G. So they are not just building their functions in a virtual manner like VNFs, they're also optimizing the VNFs for the cloud by making them stateless and dataless. So they're saying, their quote is, a data-centric network with a shared data repository will be more robust, easier to manage, and enable massive scaling while reducing the signaling traffic substantially. So they see this as being an integral part of their NFV and 5G strategy to support the dynamics of virtual functions and the scale requirements of 5G. So what makes VoltDB suitable for such use cases? The performance and scalability that a real-time, low-latency database like VoltDB provides is allowing them to have a real-time control of the network resource consumption and interaction between their network systems and the users. They give their customers an improved resiliency model with a distributed database, very low latency, which is in milliseconds or nanoseconds latency, that with near linear scaling, and highly consistent transactions so that they can rely on that their data is always correct. So VoltDB was built from the ground up to serve as a cloud-ready database. So the combination of being a cloud-ready database, being always correct, and supporting high throughput transactions and low latencies is what made Nokia go with VoltDB as their choice for the database as a service. And we find this use case in not just in other telco customers, but also in other industries as well. So if you would like to give VoltDB a try, do visit our website at voltdb.com, and you can try our community or enterprise version by downloading from our website. And from that, back to you, George.
Thank you very much, Sita. That was really interesting and good to hear of the deployment that you have with Nokia. That looks like a very interesting model for the future. We've had some questions in, which I'll soon be putting to both Sita and John. There is still time, probably in the next 10 minutes, if you're quick, to ask another question. So I'll turn immediately to the first question that I have, which I'm going to put to John Abraham from Analysis Mason. John, the question is, telcos in general love standards, and I'm sure we'll agree with that. Is there an initiative that is trying to define a consensus about what cloud native means when we evaluate a virtual network function? John, is there a consensus about what cloud native means?
So I don't think so. I don't think there is actually a consensus yet. I certainly think, yes, operators are certainly pushing NFV vendors to re-architect, their solutions around the cloud. And what we are actually finding, this again from a recent research report that we did, is that some operators are pushing for the development of their own cloud-native VNFs. So the likes of, in Europe, for instance, the likes of Proximus, Swisscom, and Telia put out a call for innovation for NFV startups, mainly with the idea of encouraging some form of a cloud-native VNF development. So I think it is accepted that new tooling is absolutely urgently required, but at the same time, I don't think it's fair to say there is no consensus per se yet. Back to you, Judge.
Okay, thank you. Let's move on. Sita, I've got a question for you that's coming. It says, how can you architect microservices and avoid adding increased latency because of multiple services in place of a single monolith?
That's a good question. So that's one of the questions that is asked when you are breaking down the system. Instead of just in procedure calls to other modules, what you are doing is you're breaking it up into HTTP calls, which come with a latency. So that's one area where a highly transactional database can help. So if there was all the data was put in a central location, and having the data in central location lets you correlate your requests, lets you have one consistent place where you can look up your data, that actually reduces the latency. So instead of having each service having its own data store that does its own thing, having a central data store helps in reducing latency.
Sure, thank you, Sita. Let's take another question, which I think I'll probably put to both speakers, but I'll put it to John first. What do you think is the timeline for the mainstream adoption of cloud-native technologies, John? I think we may have lost John. I'll try to... sorry, John.
Hi, George.
Sorry, shall I just read the question again? Yes. The question is, what do you think is the timeline for mainstream adoption of cloud-native technologies?
Right. So I'll answer that question from an operator perspective, mainstream adoption of cloud-native. See, I think mainstream adoption is at least 5 years out. I know it sounds like a long time, but going back to my picture about the true believers on one side and the skeptics on the others with the hybrids in the middle, I think mainstream is when you have the hybrids getting in on the bandwagon pretty much. And I suspect that it'll take a few years. I suspect 4 to 5 for us to get there. Yeah. So there you go.
Yeah, I guess the question is, how do you define mainstream? And you would have to say a very large chunk of that hybrid group will be the kind of tipping point that sets the balance. Sita, what do you think is the timeline for mainstream adoption of cloud-native technologies?
That's excellent answer from John, and I agree with you, George. How do you define mainstream? I think the maturity of the products that are available for telcos to use, telco-specific platform as a service, which I believe there is one product, if I'm not mistaken, is out there. So I think I would want to see more of these products in the telco space, and by that I would, looking at that, I can say, well, the industry is reaching maturity in adopting PaaS. So there's just one product right now, so I'm still not sure, but I will defer to John's estimate of 5 years to say it's going to be on mainstream.
Could I sort of dial in a bit closer on this, Sita, and think, instead of talking about maybe the mainstream, when do you expect to see more products arriving on the market? Are we looking at kind of mid next year, or do you think something might happen as early as the first quarter of next year in terms of a few more products coming into the live environments?
So Nokia is sounds like it's ahead of the curve here in the market. So together with Nokia, we're going into new markets in Asia where new CSPs are looking to implement their NFV, rewriting their course as NFV. And Nokia is already doing a cloud native approach. They already implemented a cloud native approach to their central core. Maybe not all of the modules. So I think at least from that one customer perspective, in the next year or so, I think they'll have a pretty decent implementation that can say, yeah, that is cloud native.
Yeah, so it's starting to gather some momentum through 2018, I guess, would be the general outlook, and we'd be going beyond that. We're speculating, so we should probably stop there. Great, excellent. I'm afraid we've run out of time today. It's been a fascinating session, and I think what's very interesting is this is quite a new area, and particularly new within the telecoms market. So my thanks to John Abraham from Analysis Mason and Sita Somagani, a solution architect at VaultDB, for lifting the lid on microservices and helping the demystification process, which I think will be ongoing in the telecoms industry for the next few years. Thanks again to the panelists, and thanks to you, the audience, for joining us today. And I look forward to welcoming you to another Vanilla Plus webinar in the future. Thanks very much, and goodbye.